All right, welcome everybody to today's Getting Started with Kubernetes and Rancher online training. Really excited to have you all. This is the first session of 2019. So happy New Year. And we have a
Happy
ton
New
of people.
Year!
Happy New Year. That's right. Happy New Year from Rancher. Happy New Year from the Rancher training team. We're so excited to be presenting this material to you today. We have a lot of people joining the line. So as that's happening, I just want to let everybody know that this session is being recorded, and you will get the recording. You'll receive the recording and the slides and the Q&A following the session, hopefully within the next 24 hours. So with that said, let's go ahead and jump in. We have a lot we want to go over today. We have about 90 minutes together to cover these topics and to get to all your questions. So we do want to give you, a solid technical introduction to what Kubernetes is, using Kubernetes with Rancher. And we do have slides to go over the fundamentals, go over these concepts, but this is going to be mainly about demo, mainly about seeing how these technologies work. So it won't just be, death by slides. We want to make this responsive, so please put your questions into the chat. This is meant to be interactive and really to serve you guys and you all in what you came to learn about. So if we're not covering something, please put it into the chat. This is an intro level training, so if something is kind of outside that purview, we might refer you to other sources, but we'll try to get to every single question before the training ends. And we also really want to improve our training and improve our ability to give you the kind of information that you need. So we do have a survey at the end of this training. So if you can stay on for a couple extra minutes to take that survey, that would be awesome. And it also will be sent to you through email. Just a way of introduction, my name is Matthew Shear, sort of like a community advocate at Rancher, helping with a lot of the trainings and content. We also have, so everybody knows, a Slack channel just for this training, sort of like a classroom. The channel is training-0110 for the 1st of the January 10th. And
Crazy.
if you
It's
go,
like binary. It reads the same in reverse.
I know, whoa, that's
What
crazy.
a cool date.
It was a cool date, everybody. This is the date to be at. This is the training to be on. Um, And if you go to slack.rancher.io, you can join the Slack channel and join that particular channel too. And you can get to know each other there. So please ask your questions of us in the GoToWebinar, GoToMeeting chat. We will be able to address those directly during this training. But if you have further questions, and questions of each other, want to get to know each other, see what other people are doing with Kubernetes, with Rancher and these other technologies, then, get on there and get to know each other. And last but certainly not least is our trainer on the line, who Adrian Goins, presenter par excellence. Awesome to have Adrian, as
Hey,
usual.
everyone.
All
I'm the
right.
guy with all the side commentary and the witty repartee. You just
That's
ignore me
right.
until I start talking.
And the tattoos. Cool. So little bit of background before we jump in. This is meant to be an intro to Kubernetes, so we hope that you have some understanding of Docker containers. If you don't, coming into this session, don't worry about it. I think you'll get a ton out of this training anyway. Kubernetes is built on many Docker concepts, many container concepts and technology. So you'll learn a ton. We also have a lot on our blog, on our docs around containers. We've been doing it for years. And of course, there's a ton of material on Docker themselves for more on containers. If you want to follow along with your own instance of Rancher going, you can deploy it really quickly. It just takes a couple steps. Go to the website, rancher.com, click that deploy button in the top right corner, and it'll bring you to this quick start guide. And you can get your own instance of Rancher going and follow along. It's all free and open source. Further resources, as I mentioned already, the Slack channel, slack.rancher.io, hundreds of people on there every day asking questions, answering questions. There's thousands of members. And also our forums for more in-depth conversation and more historical threads that you can see as well. Both, of course, are free for anybody to join. So with all that out of the way, we can get to the meat of the material. I'm going to pass this presentation over to Adrian. He'll take the reins.
Adrian's totally not ready. Adrian's hunting for PowerPoints in the background.
It's okay.
Windows open. Okay, Adrian will start sharing his screen. Oh, Adrian
Yeah,
shared something.
there you go. I do
Hey,
see your screen.
wow, it magically selected the right screen. That's
Yay.
great. Whew, except I'm on the wrong slide. There's me. Hey. All right, so I'm going to do some stuff a little differently. At pretty much every training that I give, I get super excited talking about all sorts of stuff, and we run out of time. We have a lot of people in the session today. How many people are here? Oh man, we have a lot of people today. So that means there's going to be more questions, and I need to make sure that I leave time for that. So I'm going to burn really fast through the preliminary information, and then we're going to get right into the nitty gritty. And I'm even going to go kind of fast through that just to make sure that I can touch on all of the points. I will pause more often for questions. I'm going to pause for questions after each of the sections. So we're going to have a section on pods, and then I'm going to pause. Try, if you can, ask your questions about pods. Matthew, if you see questions that aren't relevant to the particular section, save those until a little later on when like I'm doing the Rancher installation and we're all sitting around for 4 minutes while it happens, and we can start to hit those questions then.
Perfect.
So yeah, so let's go. If you're here, you know what Kubernetes is, and that's great. There are so many people here that I imagine that there's a broad range from people who don't really know anything about Kubernetes or maybe even Rancher, and you're looking to, well, you're looking to start down this path, or people who've actually used it, or maybe even people, you know, who've got some chops and you guys know what you're doing. That's okay. We're going to start from the basics and we're going to work our way up. I often hear people who are actually pushing back against Kubernetes saying that, you know, it's too complex or, you know, whatever. You cannot deny that Kubernetes has taken over the marketplace. I mean, there's these bullet points on the slide, which I'm not going to read because you guys can read yourselves. But honestly, even if you don't believe in Kubernetes, you still need to learn how to use it. And it's because if you don't, in the near future, you will find yourself unable to compete for a job. And that ultimately is what matters. You can learn how to do these things. You can become excellent at doing these things and look at it as an investment into your future. All of you probably know people who don't know how the internet works. And you can see today how difficult life is for them. All of us who work in IT, at some point in the not too distant future, every single thing is going to somehow touch Kubernetes. So the fact that you're here indicates that you've already probably figured this out, and we are so glad to have you here. I can't skip slides because I'm on the wrong thing. All right, so despite having massive participation from pretty much what seems like everybody on the planet, Kubernetes still has its challenges. As you read through these questions, do any of them sound like things that you yourself have asked, or perhaps things that you've heard asked by your coworkers or your employer or at meetups or anything? These are real concerns that Kubernetes users have every single day. Whenever we make a decision about a particular piece of technology, I mean, none of us want to build a thing and invest the time and energy to learn how to do it just to have it be irrelevant tomorrow. So we want to make sure that whatever we choose today not only satisfies our requirements for today, but has the flexibility to adapt as our needs change in the future.
Hey, Adrian, I'm just going to jump in because we can see your notes. So I think if you could do the
You're looking at
slide.
the wrong screen.
Yeah.
Oh yeah, look at that. You are. Okay. I'm going to show. So it did not pick the right screen.
No, it was
So
go
you
to
can
him.
see that I write out
There
slide
we go.
notes that I can read because that makes it a lot easier to do a presentation. There's your presentation tip for the day. All right. So now you're on the right screen.
Yes, sir. Thank you.
Okay.
Good
Good.
job.
Good. I gotta skip to. All right. So you're at a training session on Kubernetes and Rancher. So it's to be expected that we're going to tell you about Rancher. So all of the questions I had on the previous screen and more, monitoring, authentication integration, user management, multi-tenancy, multi-cloud, multiple means of access, security, all of those things are things that Rancher solves. So you can pick whatever Kubernetes solution you want. You can build it yourself the hard way, which is this badge of honor that people wear unnecessarily. You can put it in the cloud. You can use a hosted provider. It doesn't actually matter where you get your Kubernetes from. We can manage it. So we can launch instances and install Kubernetes onto them. We can deploy and manage hosted Kubernetes solutions in any provider. We don't even list DigitalOcean here, but if you launch something in DigitalOcean's new service, boom, we can talk to it. Just import it, works great. I've been using it myself. And in fact, for my personal cluster, I'm in the process of migrating from Amazon to DigitalOcean because I like it better. So back on point though, if you have a Kubernetes cluster in the wild, we can even import it. Like where your Kubernetes comes from doesn't matter. It's a commodity. We can manage it. But what does management mean? It means that you can corral all of your clusters under a single system, under one highly available point of control, and that you don't have to sacrifice any of the individual cluster independence. This is important. It means you can bundle namespaces into projects, you can map strong authorization roles that grant the correct level of access to those projects, and you can restrict those projects and the resources inside of them from communicating or even being able to see anything else that's running in the cluster. Single cluster multi-tenancy. You can plug it into your existing Active Directory or SAML infrastructure. You can apply that central authentication and authorization to all of your Kubernetes clusters running anywhere. It means that you can readily see and control capacity, and thus you can control your costs. You can scale infrastructure up or down based on metrics that you control. So those things are great for cluster admins. I mean, if there's anybody in here who works on the ops side of DevOps, hopefully you're finding, your heart rate a little elevated and you're getting a little excited by the potential of what you hear here. But those of you who are on the dev side of DevOps are probably yawning and wondering why you should even care. Well, maybe you're new to Kubernetes, or maybe you just want to spin stuff up and down quickly. The Rancher user interface lets you deploy applications that are as simple or as complex as you need them to be, and it lets you do so quickly. So somebody with very little skill in doing stuff with Kubernetes can still spin stuff up and get it out there and running and start to work with it while they build their Kubernetes knowledge. And somebody who has mad Kubernetes experience can go straight to the command line and have 100% access to everything, plus all of the Rancher value added on top. If you're looking for monitoring and logging, you can plug it into the existing metric server or the logging server, or you can plug it into any external system that you want. If you want traditional access via kube control, that's all still there, and everything adheres to the role-based access control that we've defined. So if you want to package your application with Helm and make it available to others, or maybe you just want to use Helm charts that other people have made, you can use the app catalog, and we can make those things available so you can spin up and upgrade Helm charts and the applications inside of them very quickly. If you're looking for CI/CD, well, you can plug Kubernetes and Rancher into any CI/CD system that you want. So now as a developer, you push your code, you can spin up entire environments for testing application onto them, bang on them for a little while for some UAT or functional testing or whatever other testing you want to do, and then tear those clusters all down again, entirely controlled from automation within Rancher. Rancher gives you total freedom, and it's 100% free and open source. Everything you're going to see today, you can go and download and do yourself. There's no community edition versus enterprise stuff. We do make money by selling support contracts, but that's up to you. You can do all of this because it's open source. So let's dive right in. Kubernetes has basic building blocks that you're going to assemble into applications. And that's what we're going to talk about today, is these basic components. Slow down a little bit here because I get very excited talking about Kubernetes. If you've done any work with Docker, there's a slight change in the lexicon of Kubernetes stuff, but don't be alarmed. It's actually pretty easy. Let's talk about pods. This is where we will begin. Imagine that you're sitting there with a container image that you want to deploy. So in Docker, you might just use Docker run to launch it, or maybe expose its ports so that something outside of the host can hit it. These are all normal things. Have you ever gone through the hassle of linking a container with another container so that they can find each other by name using just like Docker or Swarm or something like that? It just doesn't scale. Have you ever had a developer give you an application that expects MySQL to be on localhost? Have you ever tried to deploy something that worked in the development environment but doesn't actually work in production? These are all things that we're going to work on overcoming. So when you have two containers linking stuff together, not a big deal. 3 containers, 5 containers, a lot more issues. And anytime you encounter something that makes your life harder, ask why you're using it. Like, we want technology to make our jobs and our lives easier. So if something that you're doing is just not working, either you're doing something wrong or it's not good technology. Anything that you can encounter that's a problem with Kubernetes, we can overcome with training. You just need to be patient and understand that this is a learning experience, and we'll get through it together. So back to pods. Pods are the smallest unit that can be deployed in Kubernetes. They collect containers into a shared unit with combined network space and storage. That's it. A pod is simply a collection of containers that share network space and storage. So 99% of the time, you're going to have one container per pod. Sometimes you won't, but most of the time you will. If you're one of the people who's just coming here from Docker and pods are confusing, whenever I say pod, just think container, and that'll get you through today's training session. Anybody who's encountered best practices around building containers has run into the thing that says your container should only run one process. Great, but not always possible. If you're using Docker, sometimes it's difficult. You end up deploying supervisor, and no. Pods make that possible. Now you can have containers that do one thing. And you can do other cool stuff like attach other containers to the pod that do other things. And it makes it really easy to adhere to best practices. Pods are not confusing. We're going to skip past that. Here's a sample of a pod. So imagine here you've got a container that pulls content in from a content manager, maybe used it for uploading images or something, and then it's writing it to a piece of storage, and then a web server is serving that content out to consumers. All of this exists within the same pod. Theoretically, the web server and the file puller container could talk to each other on localhost because they share the same network space. But this is a great example of a pod that encapsulates multiple containers into an application that performs some function. Now, it's important here that you don't think that I'm suggesting that you run MySQL and a web server in a pod, because that doesn't scale. When you think about pods and how to assemble them, you need to think of them as a unit. So if your application needs more oomph, you're going to start by going from one pod to 2 or 3 or 5 or 10. And it's what's inside the pod that matters because you are actually cloning it. So you're not going to scale to 10 MySQL instances, each of which thinks that they're the only MySQL on the planet. No. But you might scale your web server app, or you might scale something like this that does some external pulling and some internal delivery to outside consumers. When you launch resources in Kubernetes, you create a manifest. Manifest is YAML. YAML in wittiness stands for yet another markup language, because for some reason we're all super nerds, and that's funny. You use a command called kubectl, 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 whatever. You use that to apply the manifest to the cluster. So here's a basic manifest for a single pod. It has all 4 required keys for a manifest, which are API version, kind, metadata, and spec. We're going to go launch this. It's a really simple pod. You can see down in the command part that it's going to simply echo some text, sleep for 10 seconds, and then it's going to exit. While I launch this, I want you to think, what's going to happen when it exits? Find my session over here, and good. I have nothing going on out there. That's nice. And I'm in the training namespace, so is this big enough, Matthew, or should I make the text bigger?
I would maybe make it one size bigger, 1 or 2 size bigger if you're able.
How's that?
Yeah. Oh, yeah. That's good.
Okay, cool. All right, so here's my pod again. Super basic. I abbreviate kubectl into KC because I type it all day long. So don't think that there's a special command. It's just kubectl. So KC apply -f pod.yaml. And you see that it's going to create, it's going to pull down some stuff, and it's running. All right. So if we watch this, you'll see it's restarted once, and it's going to update every second. and we're getting the output of the stuff. And you see now it slept 10 seconds, it completed, and now there's 0 ready. And what do you think is going to happen? Doesn't usually take this long. Kubernetes is, there we go. Crash loop back off and now running. So that's very interesting. Kubernetes, yeah, hang on, I got looking at my notes here to say if I'm supposed to explain this part yet. Okay, so Kubernetes understands when you tell it to run something, it's supposed to keep it running. So the pod, the container inside of it, exited. And Kubernetes was like, oh, that's not supposed to happen. And it restarted it. And 10 seconds later, it exited again. Kubernetes was like, oh, that's not supposed to happen. And it restarted it. And this continues until eventually Kubernetes realizes that this thing is broken, at which point it stops trying to restart it as frequently. Kubernetes is smart enough to figure out, well, something here's not right. So I'm going to back off on this because there's in some kind of what they call a crash loop. Kubernetes is smart. Now, usually, yeah, whatever. So that gets deleted. All right. So you're not usually going to launch pods. Let me go back to my notes here and see if I explain why. Yeah, okay. So you're not normally going to launch pods because you're just not. You're gonna build something. It's actually called a deployment that manages Replica Set and does a bunch of stuff. We're gonna get a little further into the Kubernetes lexicon now. So a pod is the basic unit of deployment in a cluster. Above a pod is a thing called a replica set. Replica set is a resource that tells Kubernetes the scale and state for a group of identical pods. For example, if you tell it that you want 3 replicas, which means 3 copies of a pod, and there's none, it's going to do its best to make 3 of them appear. So here's 3 nodes, each running 4 replicas of our pod. Kubernetes has been kind enough to spread them across all 3 nodes evenly, because Kubernetes is awesome. One of our nodes dies. Oh no, the end of the world is upon us. Kubernetes saw that the node died. It understands that we want 12 replicas, and it's able to see that it only had 8. So it did what it does, and it moved us from the actual state to the desired state. These are important terms. Kubernetes manages state. It is always working to maintain the desired state. Anytime the actual state deviates, it does what it has to do to move it back to the desired state. It'll do this it'll figure this out. It monitors the health of the pods, if they're up, down, what they're doing, but you can also set health checks via HTTP, TCP, or you can even run a command within the container because they're just Docker containers. So it'll Docker exec something that returns exit status of 0, and it says, okay, things are cool. If it returns something else, Kubernetes will kill the pod and restart it. There's 2 types of health checks, liveness checks and readiness checks. A pod won't receive any traffic until it passes the readiness check. So you think of something that boots up and it needs to prime a cache. You can configure health checks to also start after some kind of interval. So perhaps the pod takes 60 seconds to boot up like GitLab does. And so you don't want to start health checking and then killing off the pods before it's ready. So you can set these things where you say, wait some period of time before the pod is ready and then continue to do checks to make sure that it is alive. So I'll show you replica sets here in a demo, and then I'll pause for some questions. So Matthew, you can start preparing.
Cool.
All right. So the thing is, if you have a pod, you just have a pod. You can't do anything else with it, really. You can't scale it. There's nothing really managing it other than start, stop. You're never going to launch pods by themselves. You're just not. You're also never going to launch replica sets. But it's important that you understand how they work so that I can explain deployments in a second. So here's some YAML for Replica Set. It's got the same 4 items. You can see here we're giving it a name and we're assigning it some labels. Labels are very important to Kubernetes because it uses labels to figure out what it's doing. If you have a replica set that's monitoring some pods, you tell the replication controller, you tell it what it's supposed to look for. So in this case, the replication controller is going to be looking for pods that match either tier is front end or something else, or directly tier as front end. These two are actually redundant. I just have them both here so that you see that there's multiple ways to match labels. Then it has a template that it's going to use to launch the actual pod. The pods that they launch will say app equals nginx and tier equals front end. And then we define some containers and some various other things around them. So if we apply this, and then I start looking at the pods, now you see that we have let's see, we did this way. Launch. Okay, so the replica, we built a replica set, and that will consist of 3 pods, and it's in the process of spinning these up. And it's better than launching pods directly. We could, for example, scale them and such, but it's not the way that you want to do it. Normally at this point, I show you that we could like change the image of a pod and it doesn't actually update until you do something else. But that's one of the things that's the time sink. Just understand you have a pod. Above that, you have a replica set. And now we want to do something or talk to something that controls replica sets. Those are called deployments. But I'll pause to see if we have any questions about pods or replica sets. Matthew?
Sure. So Chris asks if you can go into more detail about the health probe check and how they restarted the pod?
Yeah, sure. So health checks, as I said, you configure them. I'm not going to configure one because it's time consuming, but you configure them as an instruction to Kubernetes to monitor the pods. It will execute a health check at some interval. You could say every 10 seconds, connect to port 80 and issue a get slash. And it will do that. And as long as that returns a 200 or a 300 series response code, which is OK or redirect, then it'll accept that as fine. If it returns a 400 or a 500, which is basically like a 404, so 400 are temporary errors, 500 are permanent errors. We've all seen the dreaded 502 and 503. And of course, we all know about 404s. Those are permanent, well, those are errors. So if it sees one of those, Kubernetes will do the equivalent of that. It'll just nuke the pod. And now the desired state, well, that was really fast. Now the desired state is different from the actual state. The desired state is 3 pods. The actual state was 2 pods. And you see that it just spun up a new one. Next question.
Okay, cool. Pratik asks, this is a follow-up, so during the restarts of a pod, is availability affected?
That depends. That's an excellent question. Availability is determined by what's sitting in front of it. So when we get a little further down, we get into like load balancing with services and ingresses and stuff. If you have a service in front of a bunch of pods and one of them goes away, Kubernetes, the way that it does services, the service is immediately updated. So there's no chance that any traffic will still be sent to that pod. Now, granted, if there was traffic connected to it at the time that it died, sure, those sessions are going to reset, they're going to reestablish, they're going to land on a different pod. When a new pod is launched, only after it passes readiness and liveness will it be put into rotation. So you may have seen earlier, I mean, these are really fast to launch pods, but if it says 0 out of 1 here under ready, it means that, yeah, the pod is running, but it's not yet ready. It's not receiving any traffic. And only once it passes the health checks will that go to 1 out of 1 or whatever, however many number of containers are inside of it.
Awesome. Okay, sweet. So here's the next one from Vijay, who asks, what's the difference between a replica set and a replication controller?
Replication controller is a controller that manages replica sets. You're never going to use it. You're going to use deployments instead. That'll make sense when I have a deployment demo in a second.
Okay, cool. Here's another one from Wasim. What would be the best practice for what to put into a pod? E.g., have several instances of the same component for failover in a pod, or spread them across several pods?
You would spread them across several pods. Your pod is one instance of your application. So think of if you've ever built anything on like, whatever. If you've been in the industry for long enough that you remember when we had physical servers and you would have like 4 web servers, you wouldn't put 4 copies of Apache on one physical piece of infrastructure and call that fault tolerant. No, you would make multiple servers and you would put your web server across all of them. Pods are simply a replacement for, in the context of your application, they're a replacement for a physical location, and you want to be able to shoot any one of those physical locations in the head and have the others not be affected.
Awesome. Okay. Okay, here's the last one that's been asked on this topic.
Okay.
From Renalini, who asks, where are we specifying the desired state?
Oh, right there. So we, in this case, as we launch a replica set, we want 3 replicas. And you see here we have 3 replicas. So if I shoot one of these like I did here, well, now there were 2, so it launched a 3rd one because that's what we want. And in deployments, I'll show you how we can scale these up and down so that we change the desired state based on image and other stuff.
Awesome.
Okay, that was the last one?
Yeah, well, somebody just asked.
Oh, under the wire.
Questions. Yeah, I mean, there's now a couple more pod questions. Can pods communicate across namespaces?
I'm going to delay that answer until I talk about services. Technically, yes, but you never want to communicate directly with a pod. But I'll show you how that works. Yes.
Okay, cool.
Yes.
Okay, and then here's the last one on pods failing, which is, how do you debug when a pod fails continuously?
I will cover that in deployments, and I'll show you 2 ways to figure that out.
Okay, cool. All right, let's keep going.
Okay. All right, so I present to you deployments. I used to talk about replication controllers because before deployments, there were replication controllers. Just forget about it. You're going to use deployments. So deployment is the next level of abstraction above a replica set. They give you a really nice set of commands for controlling replicas and doing updates to images and stuff like that running in the pods that are under its control. There are other resource types that are siblings of deployments, but we're not going to cover them today because they're more advanced topics. But so a deployment manages a series of replicas. It's like your basic go-to resource. Then there is a stateful set. Stateful set is where you need states, a difficult topic to explain. In a deployment, you don't actually care about the replicas. They don't know, they're not special. You could have 10 of them, you could have 2 of them, you could delete one, they could come back. There's nothing special about them whatsoever. Compare that to a MySQL cluster where you have a master and 2 slaves. Well, in that case, that matters. Or a Mongo cluster, where same thing, you've got a master and 2 replicas or an arbiter or something like that. These things need state. They need to come up in a certain order. They need to have consistent naming. They need to be able to find each other. So for that, you use a stateful set. There's also a daemon set. A daemon set makes sure that there is 1 copy of each pod running on each node. So if you have 3 nodes, it'll make 3 copies, 3 replicas. If you add a 4th node to your cluster, poof, it's going to get a replica of that daemon set because every node will have 1. In our sample pod, we launched something that slept for 10 seconds and then died. There are jobs. A job is a pod that does one thing and then exits. And that's it. And Kubernetes isn't going to restart it because that's the purpose of a job. And then there are also cron jobs. Cron jobs are just like cron on your Linux or Unix server, or whatever you're using, Mac, where it executes a job at a regular interval. And it uses the same naming, the same configuration parameter as cron itself. So you can execute it once a minute, once an hour, once a day. I run like etcd backups on a daily basis and log rotation and stuff like that as cron jobs. So here's our replica set again. This time, instead of defining it as a replica set, we defined a deployment. The deployment created a replica set. The replica set created some pods, and each of these has a specific image. For example, 1.0 or an image tag like 1.0. Now imagine that 1.1 comes out. So we want to update it. We tell Kubernetes that we want the deployment to now run image 1.1, and it does what we ask. So in this case, it's going to start new ones. This is called a rolling update, where it's going to create new pods using image 1.1 for the container. And then as the new ones come online, it's going to the old ones, and it'll continue to roll this out until eventually we are left with 4 pods that are now running version 1.1. Now, if for some reason version 1.1 doesn't work, we can roll it back. And in Kubernetes, you can roll back to the previous state, but in Rancher, you can actually roll back to any previous state. We keep a history of the deployment since its inception, and we'll let you choose. We'll actually show you diffs in the config. We'll let you choose where you want to roll back to. So before I get to services, let me get my notes here. Yeah, let me actually show you a demo of this before I start talking about other stuff. So deployment. It's got your same 4 things: kind, metadata, spec, and interesting, this one doesn't have API because, oh no, there it is, API version. All right. So we want 1 replica, and we're going to launch pods. We want this deployment to look for pods that are labeled app equals nginx. We're going to go launch pods with label of app equals nginx, and inside of it, they're going to have a container called nginx that's going to be running this nginx image here, 1.14 Alpine. Do I still have my replica set running? Oops. So, yeah. Let's see, get pod. Let's see, set the YAML. I like to keep my Kubernetes environment clean because when I go to show you guys the pods and stuff like that, I don't want it to be confusing. So you see it's killing off the old Replica Set stuff. And all right, cool. So we are already now running our nginx pod. And that's easy. Now, somebody asked earlier, what if this was broken? What if for some reason we were in crash loop back off? Well, you can just get the container logs for one, and this one doesn't have any. So that's the same as doing Docker. So they're Docker containers. So Kubernetes is simply going to show you the output coming off of the container on standard out and standard error. If for some reason your container is bad and is logging to something internally, well, you can just shell into it. And it doesn't have bash, but it will have bash. So you can shell into your container. And that's one of the super cool things about kube control. Is it doesn't matter where your cluster is. You don't have to find the host where your container is running and do a Docker exec on it and stuff. No, it's just, it's all magic and it just does what it's supposed to do. There's also kube control describe, and I'll show this in greater detail at various other points. But this is what Kubernetes sees. So you can get information about the container. And well, in fact, we'll come back to this because I use this in the demo in a second. Kubernetes has multiple ways to do stuff. So you see here, I have this YAML, but maybe I don't want to be in the business of writing YAML. Because honestly, writing YAML sucks and it's unforgiving. And if you get it wrong, it'll give you weird errors. And if you use tabs instead of spaces, you don't want to do it. So maybe you just really quickly need to spin something up. Well, there's the kc create command. So we're going to create a deployment. We're going to call it nginx. And you see I already have it in my history there. And we're going to tell it what image we want it to use. And essentially, it did the exact same thing. If I say, so I can say get deployments, it's going to show me the deployment nginx. And if I say get deploy nginx, you'll see that besides some additional Rancher related and Kubernetes related status information, the actual body of the YAML is almost the same. I mean, we don't have to include some of these things like DNS policy and restart policy because these are just the defaults. but that's another way to get stuff up really quickly. Um, so let's use our example where we want to change the image. So you see here, we're running Nginx 1.14 Alpine, and we want to change it to Nginx 1.15 Alpine. There's a couple of ways that we can do that. One is we can edit the deployment, and this will go out and fetch the manifest from the Kubernetes cluster. And then I can simply come into here and I can change 1.14 to 1.15, but I'm going to actually break this. So I'm going to give it an image that doesn't exist. Deployment extensions Nginx edited. Kubernetes is actually pretty cool here because if your YAML doesn't validate, it will exit and tell you no. No. So, and then it leaves it up to you to figure out what you did wrong. So now you can see that we still have our existing Nginx pod running because it was going to launch a new one before it killed off the old one. So right now, even though there's a problem, our application is still running. And you see here that Kubernetes is telling us image pull back off. When you see that, you know that you've given it an image that doesn't exist. You typoed something, you got it wrong, it's in a different repository, something. But if you want to know more information about why, this is where you get to the describe command. And you see, oh, failed to pull image nginx outne. And I'm like, oh, okay. Let's undo that. KC rollout status. So the rollout status command will tell you how the rolling update of a particular deployment or whatever is working. And you see that, it's waiting, and we know that it's broken. But I can also say undo. And now it'll kill off that thing that it was trying to start, and it just rolled us back to where we were before. And now I can change the image through a different way. So here, for example, I can just directly update the deployment by setting a particular image on one of the containers in the pod. Now remember that a pod can have multiple containers. So when you use this syntax, you have to tell Kubernetes within the Nginx deployment, which container do I want to update and what do I want to update it to? Providing -- record is important on the command line because that's what allows you to do a rollback. In Rancher, -- record is implied when you do it through the UI. So we're going to do that. And now you'll see that we are container creating. The -w to kubectl get pod means it'll just wait, and when there's an update to the status of something, it will tell you. We can also, if I can get there fast enough, roll out status. There. So you see that it was waiting for one old replica to terminate, successfully rolled out. And now if we get our pod, we can see that it's just that guy. And if we go and look at it, we can see that we are now running, oops, the 1.15 image. Deployments, they make interacting with Kubernetes so much easier. KC, scale, deploy, nginx, replicas equals 3. And suddenly I've got 3 replicas. Yeah, and there they all are. If I want to scale that down, like maybe, I run Kubernetes clusters in my house because I'm a super nerd. And sometimes there are things that I don't need to have running. Like I wrote this piece of software that parses Twitter feeds, but it only runs once an hour. And so for the other 56 minutes where it's not running, I don't want it just sitting there using RAM and CPU. You can scale your replicas down to 0. Your deployment's still there, just not doing anything. And these will terminate and they'll go away. No pods, no nothing, whatever. And then when I'm ready to do something with it, it automatically gets scaled up. So these are things that deployments allow you to do that you can't easily do with replica sets, and you can't do it all with pods. Deployment questions. Do we have any?
Do have several questions. Let's see. So this is from Dan, who asks, how do you redeploy latest for a given image? I.e., if you use latest as an equivalent to a snapshot build and want to
Yep.
redeploy.
Awesome, awesome, awesome. I have a thing where I talk about using image tags and I skipped it because I don't want to run out of time. And I'm still concerned I'm going to run out of time anyway, which is lame. We need to make these we need to make these 2 hours
Right
long.
now. Yeah, we
Can't do
do.
this
Really
in
do.
90 minutes.
Yeah.
Okay. KC get deploy nginx -o YAML. What you will see is image pull policy. Kubernetes is smart. I recommend that you don't ever use latest. If you try to deploy like, just nginx, it's going to say nginx latest. In fact, let's go ahead and do this. What was this guy's name?
This was Dan.
Okay, deploy Dan. Just image equals nginx. All right, so Dan, you are now a deployment in my Kubernetes cluster, and it's creating. It's got to actually go pull. Oh, it's going to pull the entire monster nginx thing. Okay, let's see. KC scale. I can demonstrate this without it actually having to do it. Deploy Dan. Replicas is 0. Okay, so we're going to kill that. KC get deploy Dan -o YAML. And boom. If you remember the other one where I had an image tag, the image pull policy was if not present, which means if the image is not present on the machine, go get it. But if it is present on the machine, use it. But as you astutely recognize, latest, you don't actually know if the latest on the machine is the same as the latest that's out of Docker Hub. So if you use no tag, which is the same as latest, or if you use latest, it sets image pull policy to always. That means every single time this pod gets restarted, it's going to go out to Docker Hub and try to pull a new image. And it'll figure out pretty quickly if it's the same, or if it's not, it'll be updated. But in production, you don't ever want to do this. And the reason is because latest today might mean version 2.2, and tomorrow it might mean version 3.0. And 3.0 might not be backwards compatible with 2.2. So you are happily in your bed at night, asleep, dreaming about Rancher and how awesome it is, and one of your pods dies, because that's just the way that it is, and it gets restarted, and now one piece of your infrastructure is running a non-compatible version of the software. And either that results in bad user experience, broken stuff, corrupted database. It definitely does not result in you sleeping peacefully through the rest of the night. So I recommend that you always use a specific image tag for what you want. And if there is no image tag, use the hash reference, which is ugly, but at least it keeps you on a specific container build for that particular application, and that keeps you in control. That was a really long answer. What's next?
All right, that's okay. Pratik asks, deployment images are being pulled from the Kubernetes marketplace, or is it available locally?
So by default, if I'm just specifying nginx or something like that, these are coming off of Docker Hub. But I could, for example, Logstash running. Where's this? Yeah. So, my image. All right, here. It works just like Docker. If you actually specify a host before what you're trying to deploy, it's going to go out to that Docker registry server and pull the image from there, or at least attempt to. So there's not like a Kubernetes marketplace. This is just coming off a Docker Hub or something else if you tell it someplace else. GitLab, your private registry, whatever.
Cool. Okay. Next question is from Ilya, who says, what is the difference between KC set and KC apply?
Okay, good question. So KC, first of all, I'm just using as kube control because I'm lazy. And laziness is one of the best attributes to develop as a system administrator because it will allow you to do more things. Automate everything, don't type more keystrokes than you have to. And if you can stop using Shift, I even recommend that. So the difference between KC set and KC apply. If I have a file here, then I tell it to apply. Let's say I'll do the pod. So KC apply says go read this file, and I could probably tell it to like apply stuff from standard in or something. Just I've never done any other type of apply except for this. Let's see what else it'll do. Oh my God, that's a lot of help. But yeah, you see, even generally, it's just you want to apply file name. Versus KC set, I used when we already had a deployment running and I needed to set some parameter of the deployment. So I was coming in, I was saying, I'm going to set the image on the deployment called Nginx, take the container called Nginx, and set the image to that. There's all sorts of stuff that you can set. Well, I guess there's not that much stuff, but you can set image, environment variables, resources, selectors, service account, which we're not going to get into today, or subject, which we're also not going to get into today. So this is just another, I told you earlier, there's a bunch of different ways you can do stuff in Kubernetes, and KC set is a way to specify a specific change to something. I hardly ever use it. Usually I'll actually edit the deployment and come down and find the image and edit it that way.
Awesome.
Next.
Awesome. Okay.
We can do one more before I got to move on.
Yeah. Okay. Cool. So this will be the last question on deployments. If the deployment was created with a command, not from the YAML, how do I see deployment YAML that later created through the command?
KC create deploy Dan image Nginx 15-outline. See that, Dan? You're famous. Okay, so that's an example. I just created a deployment called Dan, and I just gave it an image. And if I say get deploy Dan, whoops, not dad. Say get deploy Dan, it's going to give me basic information about it. But anytime you're using kube control get, if you add the ability to type, if you add -o YAML, you will get the actual YAML. And I could write that out to dan.yaml. Go ahead and nuke that. You see dan.yaml is there, and I could then say kc apply -f dan.yaml, and it's going to go and create it. In fact, if you want, you can do kc create deploy, or make you famous too, Matthew.
All right.
-- image. Actually, because I don't want to recreate all this stuff from scratch, I'm not going to make you famous.
Okay. Cool.
I'm sorry. That was it. You had your chance. You lost it. So come back out here. Create deployment. You know what? Okay, I'm going to put you back on the pedestal.
All right.
There, Matthew. -- dry run -o YAML and output that to Matthew.yaml. And now what I've just done is I've told Kubernetes, generate all of the YAML for this thing, but don't actually apply it. That's what the dry run did. Instead, write it out to Matthew.yaml, and you'll see that that looks very much like the YAML that I was using. And now I could say kc apply Matthew.yaml, and boom, there you go.
Sweet.
It's like a magic trick.
Amazing. All right, should we keep going?
Yeah, let's get going.
Okay. All right.
Deploy Dan and deploy Matthew and deploy Nginx, and we're going to talk about services. Whew. All right. Services are important. It's funny, there's two parts of this training. There's like the Kubernetes stuff, and then there's the Rancher stuff. And really, I think the Kubernetes stuff, despite being Rancher, I think the Kubernetes stuff at this point in your Kubernetes training is more important, because without an understanding of how to do this stuff manually and what it is, you don't know what you're doing, and you don't know how to troubleshoot something when something's broken. So when we get to the Rancher stuff, I'm going to show you like how to launch Rancher, and then we're just going to go do some of this through the UI, and it's easy. All right, services. Focus. Here we go. Pods are effectively transient. You can never guarantee that a pod is going to be there a second from now, because it could die. Kubernetes could restart it. It could move something around. All sorts of things can happen to your pod. So despite the fact that the pod has an IP address, you should never ever communicate with the pod's IP because you don't know if it's going to be there. Enter services. Services exist to provide a stable DNS entry within the cluster that keeps track of the pods behind it. And it acts like a load balancer, but it's actually even cooler than that because what Kubernetes does, Kubernetes networking, Docker networking, all of this is based off of IP tables. So it essentially maps the service's IP directly to the pod IP. So it's not like you're hitting a software load balancer that adds latency as it routes to something. It's not. It's all direct routing within the kernel network namespace on the operating system itself. So it's blazingly fast. But as pods come and go, the service is instantly updated to keep track of that. Now, there's various types of services, and they all build on top of one another. There's cluster IP. Cluster IP, I should actually have that reversed in my notes there. Cluster IP is an address within the cluster. You can use this for communication between deployments in your cluster. You can also use it to communicate across namespaces to other pods. Somebody asked that question, but you're not actually communicating with the pod. You might have a pod in one namespace and it needs to consume something off of a pod in another namespace. You're going to put a service in front of those other pods, and your pod in one namespace is going to talk to the service in the other namespace and do stuff. Now, there's no guarantee that that communication will work because you can also have network policies in place that say, that's not permitted. Or you could have namespace isolation that says, oh, hell no, you are not talking to another namespace. By default, it's open, it's all configurable, and yes, it's totally possible. So cluster IP, internal communication between the cluster or as an endpoint target for something like an ingress. Then there's node port. When you deploy a service of type node port, it actually creates a cluster IP service, and then it creates a node port service. The node port opens a port on every single host in the cluster. That port is in a high range. By default, it's between port 30,000 and port 32,767, 32767. These are really high ports. By default, it's also randomly chosen from one of those ports. You can specify it, but you don't want to be in the business of managing ports. You just don't. So you're not going to use node port unless you have something outside talking to the cluster, such as an external load balancer. Third service type, load balancer. If you deploy Kubernetes within a cloud provider, AWS, GCP, vSphere, there's a limited number of cloud providers that are supported by Kubernetes, but they carry additional benefits, such as if you tell Kubernetes that it's inside of AWS, then when you tell it to allocate persistent storage from EBS, it knows how to talk to the AWS API. You give it a service account or you put it on a host that's allowed to do it, and it goes and it makes storage for you. You can define a service of type load balancer, and it will go off and it will happily launch an ELB or an ALB or some type of load balancer, whatever Amazon calls them today. And in actuality, it creates a cluster IP service, creates a node port service that points to the cluster IP. So now every single node on your cluster is listening on some port. And then it goes out and it creates an Amazon load balancer, and it tells the load balancer to send traffic to the ports on every single one of the hosts. Do you see how this all builds backwards? As the service moves around, or if it gets recreated or the ports change or something like that, it will update the Amazon load balancer so that it's always pointing at the correct ports on the correct hosts. If a host leaves and a new host joins, it'll make all those updates as well. Cluster IP, node port, load balancer. You can also do a thing called a host port. You're never going to do it, and I'm not going to talk about it today. We don't have any time. It's never enough time. So services look like this. I'm not going to explain this because it's pretty obvious. You've got a thing, it talks to a thing, it talks to some other stuff, and the magic happens. But I will show you a demo of a service. So for that, I actually still need my Nginx deployment. That should be up and running, which it is. So remember, there's lots of ways you can do things in Kubernetes, whether you're a command line ninja, whether you're lazy, whether you like a UI. I will show you lots of different ways to do things. If you have a deployment that is running, you can simply expose it. And this will work. Let me look at my notes here and see if I explain when this will work and when this won't, if we have enough time to do it. We don't have enough time to do it. Okay, so notice down here, I specified that the container is exposing, essentially, the container is listening on port 80. This is important. You don't always have to do this, but if you don't do this, then simply saying expose, deploy, nginx, via whatever thing. I didn't clean up after myself. Hey, look at that. You see delete. Service, nginx, service. I give these trainings every week. Okay, there we go. So it says service nginx exposed. Cool. And what it just did is it created a node port service. This is where it's listening inside of the cluster. And it mapped the container port 80 to some randomly chosen port on every single one of my Rancher nodes. Without that deployment specifying where the container is listening, that would have failed. So if that fails, if you get a weird error, then you just have to tell it what port it's targeting. We're not going to get through that today. What we are going to do is we are going to say this is 32419. So we'll come over here to my browser, and we'll go to Rancher 01, 32419, and yay, we can all clap our hands. It's the default nginx page. And if I were to change that to Rancher 02, yay, it's just like I said it is. That port is open on every single one of the nodes in my Rancher cluster. Cool. Now, let's see. I'm going to eliminate all this stuff because of time. Yeah, we're going to skip all that. I'm going to delete this. Delete service nginx. Are there any questions about services before I start talking about ingresses?
Well, there have been a couple questions. Let's see. Does it matter if I write type : load balancer, all lowercase, or type : load balancer with uppercase L and B?
It's a great question. I have no idea. Let's find out. If I type equals node port, wah, wah, wah. Camel case. It matters.
Okay, sweet. One more. Can we use JSON also, or is only YAML supported?
Oh. You can get it to spit out JSON, which means you can probably get it to read JSON. There's probably some flag that you give it that tells it what it's looking at is. Let's see here. QC planner touch JSON slash deploy to dot JSON. We'll see how intelligent Kubernetes is. Let's see, delete, deploy nginx, and let's see, kc apply dash up, deploy to dot JSON. Hey, look at that. It'll take JSON.
Nice.
Magic.
Awesome. Okay, here's one more. Peter, Marquez says all JSON is valid YAML. So okay. Peter asks,
wow, he's a bigger nerd than I am.
Yeah, that's great. That's our people. In the YAML, you've used priv IPv4. Is IPv6 supported? And if yes, is FDOO private IPv6 supported?
I don't know. That's a super complicated question. I don't know the state of Kubernetes and IPv6. I'm annoyed that where I live, I can't get IPv6. But yeah, the answers for that are going to be on Google.
Okay. Okay, cool.
Sorry.
That's it. All good. That's it. You can keep going.
All right. I don't understand how it is that I've eliminated portions of my training today and I'm still going over time. I think I just talked too much. But it's like this stuff's important. It needs explanation. It needs context. It needs to be delivered from a theatrical stage. Okay.
something, something like that.
Ingresses. Okay, just to recap at this point, we had pods. Above pods, we had sets. Above replica sets, we had deployments. Above deployments, we have services. And above services, we have ingresses. You can deploy a service of type load balancer, and it's going to go and create a load balancer for you. Cool, no problem. Or you can use, like personally, me, myself, I don't like paying $18 a month for every single website that I want to expose on my Kubernetes cluster. That's how Amazon makes money. Good for them. Instead, I put up one load balancer and I send TCP traffic on 80 and 443 to every single node in my cluster. And every single node in my cluster runs what's called an ingress controller, which is by default an instance of Nginx acting as a load balancer. But you can also run, there's lots of different ingress controllers. There's HA proxy, there's traffic, which does some really cool stuff. But the Nginx ingress controller is what we ship with. It's like the default for Kubernetes, I think, but whatever. So an ingress is a layer 7 load balancer running inside the cluster. That's it. You can do name-based virtual hosting, which is essentially routing by hostname. You can do path-based routing. So if you think about a microservices deployment, you might have /store running in one set of pods and /search running in a different set of pods. And off of your ingress controller, you can now route those things correctly, which you would not be able to do if you were just using service of type load balancer. So the ingress controller does actually give you additional benefits around making decisions on how your cluster is going to behave. And it looks like that. That's pretty self-explanatory. Oh my God, config maps. We don't have time for that. Let's talk about ingresses in the demo. All right. Hey, let's get rid of Dan and Matthew. Sorry, guys.
Okay.
It's been fun.
Yep, we're done. We're out. Next.
Yeah. Okay. So I'm going to give you a demo of two different types of ingresses. Do we still have a deployment running? We do. Yes, and it's good and it's healthy and that's great. And how many pods do we have running? One. Let's just make that 2 for that. Here is some simple YAML for ingress. So it's got a name. It's got an annotation. Annotations are how you add additional configuration to the ingress controller. I'm not going to explain what this particular one is, but whatever. You can do things, you can do all sorts of cool things with writing Nginx config here. But the rules are what matters. The rules are what matter. So here we have a host name. We're going to call this training.cl.minoc.us, which is my internal cluster name or domain name here at my house. We're going to send / to the service called Nginx, and we're going to send it on port 80. Do I have a service running? I don't. So I don't actually have to say type equals cluster IP because that's the default. So I can just do that. And you see that it created a cluster IP service. Yay. And so that's listening on port 80 inside the cluster on this particular IP address, and it's going to send traffic to wherever it's supposed to go. So if we apply this, oh, I still have my fan out running. Okay, so we have a single ingress, and in a moment it should actually pop up where it's listening. Whatever. In the meantime, let's go over here and let's go to, and there you go. Do this update. Oh, okay, so maybe it doesn't update. But that's it. So training.cl.minoc.us is hitting port 80 on something. Actually, no. Where's that going? Ah, okay. So here's an example. This is an HA proxy load balancer that I run inside my house. You can think of this as an Amazon ELB. And this is simply sending all HTTP traffic that doesn't go somewhere else. By default, it just goes to the Rancher cluster. So when the traffic hits here, it arbitrarily chooses Rancher O1, O2, or O3, and it sends the traffic to it. And that's why we are seeing this. There are other solutions. If you're running a cluster in an environment where you control the IP space in your data center, in your house, something like that, there's a really cool project called Metal LB. And Metal LB, I moved my tab bar today. Metal LB does, you give it a block of IP addresses and it does layer 2, essentially proxy ARPing. And so it will pick a host and it will ARP for an IP address when you set service type of load balancer. So it's essentially, it's a way to set service type of load balancer and have a software load balancer deployed as part of the service, in which case it's a one-to-one map between the application and the load balancer. It's cool. I choose to run HA proxy because I run other things besides Rancher inside my house that I need to send traffic to. There we go. That finally updated. So you see that the ingress is running on all of my Rancher nodes, and life is great. Now, let's step this. Man, I'm not even going to get to the Rancher installation today. This is madness. I hope you guys can stay.
Yeah, we can stay longer. I can certainly stay.
Yeah, so we're gonna extend this to a 2-hour session. If you guys can stay, you're welcome to stay. But if you can't, at least you got the Kubernetes portion. So imagine that we had multiple applications. My earlier example of /store, /search, something like that on different paths. So if I show you a fan out here, you'll see that I now have 2 paths. Slash is going to go to the Nginx service, and /rancher is going to go to the Hello World service. So we'll build that. And it is undoubtedly out there running because it's fast like that. And if we reload, this doesn't look any different because it's not. But if I say /rancher, we're going to get, boom, 503. 503 invariably means that the backend does not exist. And that's true because we don't have a service called Hello World. So where's it going to go? Can't go anywhere. Oh, thank God for tab on completion. So let's start that. We're going to build a container here. Let's expose it. And that's going to fail. That's going to fail. It tells you why it failed. Because I told you before, when you just do that initial deployment without specifying the container port, it doesn't know where to go. So that's what it says. Couldn't find port via -- port flag or by looking at the deployment. So we can fix this by just saying port equals 80. Oh, now it's happy. So we've got our service. We've got our pod running. And hopefully, boom, now we have 2 different sets of pods, 2 different deployments running under the same host name on 2 different paths. And you see, this actually shows me the container. So if I were to git scale deploy hello world, I scale it up to 3 replicas. All right, they're running. They'll end up in rotation, and we should start seeing, there we go. You start seeing this change as it load balances across the various containers, or the various pods in the deployment. Okay, there's more that I can show you with Kubernetes, but we don't have time for that. So are there questions about deployments before I jump into the Rancher stuff?
Well, there's some ingress stuff still.
Sorry, not deployments, ingress, that's what I meant.
Okay, cool. So Leonardo, you might have actually answered this one in a way. Leonardo asks, on a bare metal internal cluster, do I need to place a load balancer in front of my cluster to manage ingress controllers deployed on each of my nodes? If so, what are your thoughts on using Metal LB and a service type equals load balancer to do that balancing?
Okay, Metal LB is great. If you are simply using service type of load balancer and you just have self-contained applications and you don't need to do the multi-path routing type stuff here, metal LB is fine. Um, because service of type load balancer isn't very intelligent. Ingress was created to add intelligence to your load balancing. So where you put that intelligence is up to you. You can't put that intelligence into metal LB because that's just routing to the service. So you either have to have something sitting outside of your cluster that sends all 80 and 443 to your cluster, and then you handle it with an ingress from there, or you have one-to-one maps. The reason that you need something outside, the counter argument is, well, what about round robin DNS? So sure, let's say www.adrian.com is Rancher 1, 2, and 3, and it just round robins between them. That'll work as long as 1, 2, and 3 are up. But as soon as I take Rancher 01 down for maintenance, 33% of my traffic will fail. So I still need something intelligent sitting in front of my cluster that can detect that failure and stop sending it traffic. For me, that's just HA proxy running on 2 nodes. They can be virtual machines, they can be something. In Amazon, it's going to be an ELB or an ALB. So it's going to be an ELB, just sending all your TCP traffic directly to your nodes so that it can do the health checking and the failover. It's whether or not to use metal LB is architecturally dependent. If you can do a one-to-one map to an application, then metal LB will serve you fine.
Awesome. Okay, cool. Next one is from Davey, who asks, does Trafic have similar performance in the default ingress or traffic?
Traffic. Yeah, I know they spell it funny, but it's just pronounced traffic.
Okay, cool.
Because we don't know how to spell on the internet.
Right.
Traffic works great. Traffic, I haven't looked at it in a while. I'm not sure how stable it is right now. When it works fantastically. I know that it's complicated, and it was still pretty alpha when I was looking at it. But it's one of the contenders. It does have features that the Nginx ingress controller does not have. If those features are important to you, then by all means deploy it. You don't need to pick just one either. Ingress controllers are designed where you can designate a default ingress controller, and then you can designate an ingress controller that responds to ingress requests with a certain label. So you might have an application that needs to go through traffic or Kong, which Kong is an API gateway that also runs as an ingress controller. So maybe you have some API stuff that needs to go behind Kong, but you don't want all of your traffic going through Kong. So you can tell Kubernetes when it receives traffic for a particular host, which ingress to use for that host, and it'll essentially do routing to ingress controllers, which then do routing to services and pods.
Okay, awesome. Next one is from Martin, who asks, do we need F5 or does Ingress do the job?
Ingress does the job. You don't need an F5. Those things are expensive. If you already have an F5, F5 has an ingress controller that works like the service type of load balancer, where when you create ingresses, it actually, instead of creating it in the ingress controller on the machine, it actually uses the F5 API, and it creates node pools and inbound VIPs and all of the F5 configuration on the F5 itself. A10 has something similar. So pretty much anybody who has an external hardware-based load balancer has a Kubernetes integration where your Kubernetes commands do the configuration. Instead of doing it in the ingress controller in the Kubernetes cluster, it does it on the load balancer sitting outside. But by no means do you need to go buy one.
Okay, sweet. Next one, with service running as type node port, how does Kubernetes ensure that the random port selected will be free on all the nodes?
Because Kubernetes is the only thing that controls those ports on all the nodes. And if you have something else running on your node that could arbitrarily choose a port between 30,000 and 32767, you've made an architectural error.
Okay, great. Okay, cool. Yeah, all right.
Matthew's like, wow, Adrian just got really mean.
Straightforward. All right. Okay, another one is from Drew. Can Kubernetes so some general Kubernetes questions. Can Kubernetes auto-configure an SSL certificate for domain, like through Let's Encrypt?
Yes. There's a cool thing called Cert Manager that will do that, and I'll try to show that. Okay, I'm not gonna be able to show. No. Hold on a second. I'll take you to one of my other Rancher clusters. Actually, I don't need to show it to you there. I can show it to you here. ACC. Uh, wow, that's crazy. What the hell am I doing wrong? Okay, there's something wrong with my Kubernetes. I'm looking at the wrong thing. Okay, so I'm not going to show it to you here. I'm not sure why kubectl isn't talking to my other cluster, but what you would do is you would deploy a thing called cert manager, and cert manager interfaces between the Kubernetes cluster and Let's Encrypt, and then you apply some special annotations to your ingress configuration that says, hey, cert manager, go get certificates for this. And when you commit that ingress, cert manager sees that because it's all a Kubernetes API, and it goes out to Let's Encrypt and it registers the certificates and it does all of its Let's Encrypt magic, applies those into the secret store, and then makes sure that that traffic is encrypted. And it also automatically handles the renewals for you.
Oh, sweet.
I was going to show you, but I don't know what's wrong with my cluster out there. It's very sad. What's next?
Well, I think that a lot of the other questions are on Rancher, so why don't we keep going?
Oh, Rancher. I don't even know if I have Rancher slides. Do I have Rancher slides? Config maps. I never get to show config maps. Config maps are really cool. This is a book. It talks about distributed systems. It's written by a dude who worked at Microsoft. It's cool. I haven't read it. It's supposed to be a good introduction to stuff. I usually say more about it, but we don't have any time. And here's Rancher. Okay. Let's see. All right. I have, first of all, when you are deploying Rancher, please use our documentation. If you go to rancher.com, you can go to Learn, go to Documentation, and over here we've got RKE. It's Rancher Kubernetes Engine. If you've never deployed Kubernetes and you're looking to deploy Kubernetes somewhere where you can just play with it, please look at RKE. It is so simple to launch Kubernetes clusters and upgrade them and do everything that you need to do. If you're launching Rancher, this is Rancher 2.x. That's what you're going to look at. Rancher 1.6 was the previous iteration of our product. Do not deploy it. It's still supported for customers that are running it, but we will not support new deployments of it. Just don't even go there. Rancher OS is a super lightweight operating system built for running Docker containers. It's very small footprint, very small attack surface, everything runs as a Docker container. There's a system Docker and a user Docker. It's really cool. And in fact, if you launch stuff out in DigitalOcean, you can even launch DO nodes using Rancher OS. But we've got all of this stuff here about how to install things. And today I was going to show how to do an HA installation, even if you only have one node, but I'm not going to do that because I don't have time and it takes too long. So I'm going to go through single node install. It's important that you understand a single node installation does not give you any fault tolerance. It is literally a Docker container that's running. We're going to do a little bit to map a volume to it so that if the container dies, we don't lose our configuration. But this is 100% only something that you do to test Rancher. If you want to do, if you think that maybe the Rancher instance that you're going to deploy today, you might start putting production workloads on, then do a high availability install. It says install Kubernetes with RKE. There's more steps involved, but it's really simple. And just do this with a single node. And that's fine. And what happens is you deploy RKE on a single node, and later when you're ready to go to HA, you just give it 2 more nodes and you say RKE up, and boom, suddenly your single node is now 3 nodes and it's highly available. That's what I was going to demonstrate today, but just we're going to do the single node, super easy. run here. The gentleman who asked about Let's Encrypt, you can even launch Rancher to automatically encrypt itself with Let's Encrypt instead of its default self-signed certificates. So that's pretty cool. But launching it with its self-signed certs is also very simple. I don't have anything running out here, do I? No. Docker run -d -, oops. Start equals a must stop -p 80 to 80 -p 443 443. Rancher. You see down here, we say Rancher latest. I recommend that you don't do that because latest is our edge build. At the very least, run Rancher :stable, or do like I recommended earlier and pick an image tag. 2.1.5 is our latest stable, and it contains all of the fixes for all of the Kubernetes CVEs that were released in the last week or so. So this will deploy the latest stable versions of Kubernetes down the road. I also add this persistent volume here, mapping opt rancher to var lib rancher. And actually, let me make sure that I don't have an opt rancher hanging out there, because I bet I do. Yeah, I do. That would have just brought up my cluster from the last training. So this will take a moment to bring itself up, and it will appear on this over here. Even before Rancher's finished doing all of what it's doing, the cluster should come up. There it is right there. So since I'm using self-signed certs, it's of course going to tell me that my world is in great danger and I should not do it, but I know better. And it's going to ask you to set a password. So we'll set a horribly insecure password. And then we will continue. This step is very important. It's asking for the Rancher server URL. Whatever you tell it here is what it's going to tell the nodes that it's deploying to use for communication back to the server. So if you are running this in your office, for example, and you're deploying nodes out at Amazon, which we can do, just make sure that this is accessible from those Amazon nodes. So this needs to be a host name or an IP or something that's sitting at the edge of your network, or just deploy the Rancher server in Amazon in some central externally managed location. And that way you can launch clusters all over the place. If you do get this wrong, don't be alarmed. You can change it later. We'll save that. And this is the global screen. So at the global level, we focus first on security. We're using the internal database for authentication right now, but if you have an external identity provider, you can connect it here. So any of these things, most of these are SAML or LDAP based. You can directly connect to OpenLDAP. You can actually use, for example, AD federated services with an alternative SAML source. So there's cool stuff that you can do here, depending on who you want to talk to in the backend. You can also set pod security policy templates here that will be applied to, or at least available for application to all of your downstream clusters. And you can define roles for global, cluster, and project. By defining all of these things, authentication, PSPs, and roles at the global level, any cluster that you build will inherit those. So you're not responsible now for managing roles and access and RBAC on a cluster by cluster basis. The Rancher server is an authentication proxy, and it will handle all of the authentication and then hand off the authorization to the Kubernetes RBAC. And now you don't even have to configure end user access directly to those clusters. Everything goes through the Rancher server. And if anybody for any reason leaves the organization, you just deactivate their account and they lose access to everything. If you need to change permissions for a team or something on a cluster, you do it from the Rancher server and it propagates out to all the clusters. At the top level here, there's a bunch of other stuff that we can do. We support various types of backend cloud providers for deploying stuff. There's only some that are active, but you can also add node drivers. Anything that you can do with Docker machine, you can drop into here and we'll provision it that way. We're just going to go right to add cluster. Here we can say we want to spin it up in a hosted Kubernetes provider, and it'll ask us for our service account or whatever information it needs to do that, and it'll reach out, spin it up, connect it back to the Rancher server, do everything that it needs to do, and do full lifecycle management of it, meaning that if we decide to delete the cluster, it's going to go out to the provider and it's going to delete the cluster as well. Same with infrastructure nodes. This would go out to Amazon EC2 and it would deploy compute instances according to the specifications that we give it, and then it would install Kubernetes into them using RKE, and then it would wire it back to the Rancher server, and you'd be ready to go off and do your stuff. We can do that with these guys by default, and then other node drivers that you saw me demonstrate earlier. If you have a cluster already running somewhere, we can import it, and we just give you a kubectl command to run on that cluster that installs an agent, and that agent bridges between the Rancher server and the Kubernetes API. And then immediately you just start communicating with the cluster through the Rancher server, and all of your RBAC and cluster policies, roles, and everything like that trickles down. Or you can just do custom, and custom is for anything that doesn't fit any of the above. And for that, we will simply give you a Docker run command. You'll see that in a second. Here's where we would define members, teams, things that are supposed to have access to this cluster, any roles that we've defined previously. And then here's where we can set various things about the cluster itself. What version of Kubernetes do we want to deploy? In this case, 1.11.6, which is the most secure. What network provider backend? Currently, these are the three that we support by default. Weave is also out there in a direct RKE installation. Do you want project network isolation? Various other things. Are you running inside of Amazon? Stuff like that. And then we'll say show advanced options. And there's even more stuff down here that you can set, like what port range do you want to use? If some other process already has the ability to hijack these ports, then you just change the range. Metric server, pod security policies, various other things. If you don't want to use the Nginx ingress controller, we won't install it, and you can install your own, which is super cool. Automatic recurring snapshots of etcd on what iteration and for what retention. And when we say next, it's going to say, okay, so we're going to give you this command, and what do you want this node to be? And since we're only spinning up one node, we're going to make it all three roles, etcd, control plane, and worker. We can give it an optional name, we can give it labels, we can do other stuff. For example, in a cloud provider where you get charged for communication with the public IP of a particular instance, you can tell the Rancher server what its internal IP is, and it will do communication with that. And it helps it understand better how to interact with the node. This Docker run command, I'm going to go run it over here, and it's going to run off and do some stuff. And that is static for this cluster, which means if you use a provisioning system like Puppet or Chef or Ansible, you can put that into your provisioner, and as you spin up and spin down nodes, you can have them automatically join the cluster. So if you don't want to use Kubernetes' own structure, if you're not in a cloud provider, for example, that allows you to scale nodes up and down, you can plug that into your external monitoring system, and it might detect, oh, load on the cluster is over 75% for the last 10 minutes, spin up 2 new nodes in Zen server, or whatever virtualization app you're using. This will take 2 to 3 minutes to install, so we can answer more questions.
All right, awesome. Let's see. Is it safe to use RKE in production?
Absolutely. RKE is amazing. So
Okay.
I'll explain a little better. RKE is 100% upstream Kubernetes repackaged into Docker containers. We don't actually change anything other than breaking it apart into its components, the proxy, the API server, the networking components, and putting them in Docker containers. This is powerful because if you've ever done a direct Kubernetes installation with kubadm, for example, you are responsible for doing initial configuration of the nodes themselves. You have to install the networking. You have to install the kubelet. You have to install this. And so now there's this dependency on the node. RKE only requires a supported version of Docker. well, a supported version of Linux as well. It doesn't run on Windows. So some Linux distribution and a supported version of Docker, and that's it. So as long as you have a node that's running Docker, you can add it to your Kubernetes cluster. And RKE in the next release of Rancher will also support ARM. So you can deploy Kubernetes onto ARM, you can deploy Rancher OS onto ARM, and you can manage x86 and ARM clusters side by side within the Rancher UI.
Okay, awesome. Thank you,
Yes.
Adrian. Next one is from Igor, who says, does Rancher make any changes to Kubernetes itself? I'm asking this question because one of our tool implementations is not working. Technical support claiming that Rancher does something different than pure Kubernetes. I don't quite follow. Can you explain?
So Rancher does not make changes to Kubernetes itself. I don't know what tool you're using, but I'm gonna take a stab in the dark here and say that your tool expects something to be deployed on the host. An example of that is some storage that wants you to use iSCSI, for example. So they say, oh yeah, just on the host, install iSCSI tools so that we have access to the iSCSI ADM command. And they expect that because they're just assuming that the kubelet runs on the host. Our kubelet runs inside of a Docker container. So you can install iSCSI ADM on the host, but our kubelet doesn't run on the host. So if it's not installed in the container, then whatever is running that's telling the kubelet run this command, the kubelet's like, I don't know that command. I don't see that. I don't have that command installed. iSCSI tools isn't a good example because we do actually have that in the kubelet, which is why you can use things like OpenEBS for persistent storage and stuff like that. But probably your tool is actually looking for something to exist outside of Kubernetes for it to do what it wants to do. So them saying that Rancher does something different, it's actually them that are trying to do something outside of Kubernetes. However, we want to make sure that you get help. So join the Rancher user Slack, find me, my name is Adrian, and give me more information about what your tool is, and we will see if we can get you a solution.
Awesome. Okay, cool. The next one, we are deploying Rancher 1.6. Is it advisable to go with Rancher 1.6? What do you think?
Don't do it. Don't do it. You can't get support for it anymore. Rancher 1.6 it's the first version of the product, and 1.6 is super stable. It was great, but it doesn't have the same level of support for Kubernetes. It just deploys Kubernetes and then kind of gives it to you to go do stuff with. It had support for Mesos and Docker Swarm, which, well, I'll just leave it at that. And we had our own orchestrator called Cattle. Um, Customers who purchased support for Rancher 1.6 are still receiving support for it, and we're still doing updates and things, but only for security. But absolutely, if you are starting down the Rancher path, you want to go with Rancher 2. We're on what 2.1.5 right now. So Rancher 2 is built on top of Kubernetes. It's 100% Kubernetes. It still has the same great sexy UI that you're going to see more of here in a second, and gives you all of the power of Kubernetes and more on top of it by making it easier to do a whole bunch of different things. So please do not deploy Rancher 1.6. Go with Rancher 2.
Awesome. Okay. Here's another one from Jens. If I have a hybrid setup, is it possible to use local load balancers but also span across different cloud providers?
If I have a hybrid setup, is it possible to use local load balancers but still span across multiple cloud providers? That's interesting. I would have to know more about the architecture. Theoretically, so it depends on how you've deployed multiple cloud providers. If you're talking about having multiple clusters, so let's come out here to the global level and go to clusters. Let's say that we had 5 clusters here, and each of them was in a different cloud provider. At the moment, each cluster is autonomous. So if you deploy an ingress controller or something like that in here, it only knows about itself. With the next release of Rancher 2.2, we will have the ability to deploy what we're calling multi-cluster apps. So I'll be able to launch something from the app catalog here, and I'll be able to deploy this into multiple clusters. And then we're doing a thing called global DNS, which is essentially global server load balancing of multiple Kubernetes clusters in multiple geographic locations, whether that's within the same cloud provider, multi-cloud providers, we don't care. Multiple Kubernetes clusters, load balancing across them all, hooray. So without knowing more about what you're doing right now, I can't directly answer that question, but you're also welcome to find me on the user Slack and give me more information, and you and I can, nerd out about architecture and multi-cloud deployments.
Cool. You want to do more, show a little bit more of Rancher, and then there's some more questions we can get to.
Okay, sure. Yeah, I'll go through the rest of my Rancher demo, which is not actually super long, and then we'll spend the rest of the time on questions.
Cool.
So you see the cluster's up, it's running. We're inside of it now. These here represent projects. By default, you get two projects, default and system. A project is a collection of namespaces. So if I were to add a namespace here, we'll call this namespace Adrian, then I'm still within the default project. The default project, now when I say I want to deploy something, it'll ask me where I want to deploy it. So in this case, it only gave me one namespace. Let me add another namespace here. So we'll add a namespace and we'll call this one, we'll make Matthew famous again.
All right.
Adrian and Matthew. Now, the reason this is interesting is let's say that Matthew and I are on a team and we're software developers. And so when I'm deploying applications to test stuff, let's say I want to deploy something and I'm going to deploy Adrian test, and this is going to be BusyBox, and I'm going to do latest because I don't know any BusyBox version. I can't break my own rule. Nginx 1.15-uptime. There we go. And I'm going to deploy this into the Adrian namespace. I have a whole bunch of other stuff I can configure here. I can add environment variables. If we have secrets or config maps, which I didn't get to show you today, config maps basically address the question of how do I configure a container. You can pull down the Nginx container, you can run it, but you're not going to run it with the defaults. So what do? Do you add a volume that has your Nginx config? Do you bind mount a file into the container? Do you add your own Nginx config and then rebake the container so that you're deploying your version of it? These are all hacks. What a config map allows you to do is you can define the entire Nginx configuration and then mount that into the container at runtime as a file. And config maps are super cool because when you change the config map, they automatically update inside of the container without you having to relaunch the container. So if you're using an application like Nginx that's smart enough to figure out, oh, hey, my config changed, let me reload it, you now can do runtime updates of your container's configuration without ever restarting your container. And that's pretty cool. So if we had config maps configured, or secrets, which are safe ways to store and mount secret data like API keys and passwords and stuff like that, we could select those here and decide how we wanted them mounted within the container. And all sorts of other things that you've already heard me talk about. So we can schedule nodes based on labels. We can set up liveness and readiness checks based on TCP, HTTP, command, whatever. We can do all sorts of stuff around persistent storage. We can control how it updates and scales. If we click on advanced options, we can change the command. We can do networking things. There's all sorts of stuff that we can do here. But we're not going to do any of that. We're just going to add a port here. We're going to say this is a cluster IP. And I'm going to say launch. Now that's me, and that's running in my namespace Adrian. If Matthew also wanted to launch something, I'm going to be lazy here. I'm just going to say clone. We're going to put it in Matthew's namespace, and we're going to call this Matthew test. Now we're still in the same project. So a project is a collection of namespaces. I could come out at the cluster level, and I could create a new project, and we could call this Matthew, and we don't have any extra user accounts in here. We could set resource quotas on it, which define maximum amount of CPU and RAM and storage that a particular project is allowed to use across all of its namespaces. And now you'll see that we have the default project, which has our two namespaces. There's also this Matthew project over here. So maybe Matthew's application, in fact, I'm just going to delete his entire namespace because it doesn't belong in my project.
Thanks.
I know, man. I set you up and I shoot you down.
Yeah.
So now in Matthew's project, use an existing namespace. Oh, I didn't create namespaces. Add namespace, Matthew. Okay, great. Deploy namespace, Matthew. Perfect. So all the same stuff that you've already seen, we'll set this to 80 and set this to cluster IP, and we will say launch. And now we can configure users. So I can configure a user account for Matthew that only has access to Matthew's project. And when he logs in, that's all he's going to see. And I can configure the namespaces to only allow communication amongst pods that are running within the namespace or within the project itself. So now nothing that I'm doing can see anything that Matthew's doing, and I don't even know that Matthew exists. So this is single cluster multi-tenancy. Having deployed my stuff, it automatically created a service for me because I told it that I wanted it to expose a port. And I could come out here and specify husband views. Actually, that's not what I want. Training push a. See if I'm locked to the US. And we're going to send slash to the Adrian test. And we'll say create. The port is required. Say 80. And then we'll say create. So that's going to go and do its thing. And I mean, everything that you already saw me do with all of the YAML and all of the Kubernetes, Rancher accelerates your ability to do that. But on top of that, it adds all of the benefit of security, namespace and project isolation, multi-cluster management, centralized policies for role-based access control, pod security policies, roles, all of those things. It makes managing clusters easy. It is fully accessible via API. It has a CLI, so everything that you see me doing that's Rancher specific outside of Kubernetes, you can still do via CLI. So you can still plug all of this into your CI/CD system and have it actually spin up hosts, fire up clusters, deploy applications. And then there's the catalog. So these are Helm charts that we curate and ship with. You can add additional catalogs yourself. Any Helm repository you can add, and its apps will show up in here. And you can also build your own. They follow a format that's available on our documentation. I mean, they're still Helm charts, but then to get them within the app catalog so that they ask the users various questions, there's some additional YAML configuration that you need to do. And if you want to deploy Kubernetes as a service within your organization, building your stuff as catalog apps and making it available to the downstream users of the service give them the ability to launch applications that you manage. So you can say, this application uses these containers on these versions, and they just come in here and they say launch. And it goes out and it spins up exactly what you told them they're allowed to spin up. And then once it's up and running, it'll say up to date. And if there's an update for it, it'll say update available, and they'll click that, and they'll come back in here and they'll do a rolling upgrade, zero downtime upgrade, and they get their stuff out there. We're 20 minutes over, so I want to show you more, but I'll save the last minutes for questions.
Okay. Well, yeah,
Sorry.
there are questions. No, it's fine. Let's see. How can we? Okay, so this is Ilya. I don't think, did you? Oh, here we go. If Rancher 2.x is fully built on Kubernetes, then what's the difference between Rancher 2.x and RKE?
Oh, that's a great question. Okay, so RKE you can use by itself. RKE is a blazing fast way to spin up Kubernetes clusters using Kubernetes running inside of Docker containers, which is RKE. It's upstream Kubernetes, but it's in Docker containers. If you wanted to just go deploy Kubernetes on a bunch of nodes that you have SSH access to, you can do that with RKE. It'll give you a kube control cluster config file, and you can just start talking to it with kube control. No rancher required. If you have a Kubernetes cluster running anywhere else in the world on GKE, EKS, AKS, whatever the cluster du jour is of tomorrow, clusters that you stood up, Minikube, probably, I think even OpenShift, like any Kubernetes cluster anywhere, you want to manage it, you can manage it with Rancher. You can come in here, you can say add cluster, you can spin it up, you can import it, you can do whatever. Not related to RKE. If you want to deploy a Kubernetes cluster from within Rancher, on cloud instances. For example, you want to spin up 3 EC2 nodes and deploy Kubernetes onto it. We will spin up the EC2 nodes and we will deploy Kubernetes via RKE. So they're complementary, but they're two separate things.
Sweet. Okay. Next one is from Arvind. I find some catalogs are deployed successfully, but are not able to access that as a service. What am I doing wrong?
I would have to see that in action.
Okay.
Perhaps give a little more information, and Matthew will come back to your question, but describe when you say can't access it as a service. Is it like, do you get an error message? Or, I mean, that's more of a specific troubleshooting thing. Put some more info in there. We'll come back to the question. If I can answer it, I will. If not, you and I can talk about it on Slack.
Okay, cool. Next one's from Colin. Where can I find documentation on how to build my own catalog?
Oh, you're going to make me go look for that. Let's see. Smooth install catalogs. And okay, so rancher.com/docs, or you can just go to rancher.com and go to learn and go to rancher docs. And when you're here, you will select Rancher 2.x. And from here, you'll select catalogs and charts and custom catalogs and charts. And on this page, we talk about the chart directory structure, the additional files to create questions.yaml, the format, everything you need to know to build your own custom catalog item is here.
Cool. Okay. Next one. This is from Marquez. Is there a name or spec for the YAML markup that annotates the Helm chart so it can render in the UI nicely?
I think that's the same thing. I think that he wants to go and look at this.
Okay.
If you import an external repository, let me show you. I'm going to show you two things here because there's also something else I forgot to show you that's important. So at the global level, you can add additional catalogs here. So I'm going to say add catalog, and I don't remember what it is here. So I'll go get it from yet another Rancher cluster. So this is the Rancher side of the cluster that you guys saw me working with in the beginning part of the training. So catalogs, this guy right here, OpenFast. So if I add this, we'll call this fast catalog URL, branch master kind Helm, and I'll say create. It's going to go and it's going to refresh it. And looks like I may have already refreshed it. And now inside of my project, I go to catalog apps and I say launch, and I look for, it hasn't refreshed yet. Refresh. There we go, OpenFast. So I say view details, and you'll notice here that all I have is key value pairs. So I would have to go and look in the README, which we include for you, to see what stuff OpenFast accepts, and I would set those things here. So it's like, ingress.enabled equals true, and so on. And say add answer, and so on and so forth. Compare that to anything that we have where we ask you questions. So this is a lot easier for somebody who doesn't necessarily know Kubernetes or what all these things are, because be like, oh, do I want a custom resource definition? No. Enable the webhook, whatever. So this stuff is the extra little bit of special sauce that you get from building a custom catalog and chart for your application or for any other application that's out there. So that's thing number one. But before we go back to questions, there's one thing that's really important that I didn't show you guys. And that is when you are inside of a cluster that you've built with Rancher, like we just did, we still give you, at the cluster level, we give you two ways to talk to it via CLI. One is we will give you a direct kubeconfig file, and you can take this and you can put it on your local machine, and you can use it to talk to the cluster via kubecontrol, like you saw me doing all morning long. The second one is we give you this nice little shell here. So if there's a simple kube control command that you wanted to run, like you needed to get the logs for something, whatever, we have that available. This is also available for you to use if you are somewhere where maybe you don't have access to kube control at the command line. So those are two other things that I wanted to show you. Next question.
Awesome. The next question from Declan. Can I set an environment variable that applies to all containers in a namespace?
I don't think so. If you could, that would be a Kubernetes thing. Oh, wait, hang on. Okay. Yes, I'm pretty sure. We're gonna test that though. Workloads. Um, all right. I have two things here. So once you have your workloads running, you can do cool things with them. Redeploy them. You can actually shell into them directly from here. Um, so here you can see that we have some stuff. This is in the Adrian namespace. And I want to go ahead and update this. So I'm going to add an environment variable. And Lester, what was that person's name?
Declan.
Declan?
Yep.
Okay. So on my Adrian test container, I'm adding an environment variable of requester equals Declan. We're going to say upgrade, and that's going to go out and do a nice rolling update, just like you saw me do when I updated the image on that pod before. Now I'm going to deploy a second one. We'll call this Declan test, and we'll use the same image because we already have it. It's going in the same namespace. That's very important. And we're going to add an entire environment variable here called other variable, and this is going to be Adrian. And I'm going to say launch. I'm pretty sure, and we will find this out momentarily, if I execute a shell into Adrian test, and I say set, notice requester Declan, and I already forgot the other variable that I used a moment ago. So in Declan test, say execute shell, set. No, okay, so it's not. In the default namespace on Kubernetes, oh no, there, yeah, so other var Adrian, that's what we created, but we don't have requester equals Declan. So in the default namespace on Kubernetes, any pod's environment variables are visible in every other pod. But that it seems to only be true for the default namespace. And since we're running in a special namespace called Adrian, that is not the case. I don't know if it's possible to force Kubernetes to do that. Yeah, I don't know if it's possible to force Kubernetes to do that.
Okay. I think that we have a couple more questions, but I think this one might be the last one. And a few people have asked about etcd. So the question etcd.
Yeah.
Can I set the version of etcd?
Can I set the version of etcd?
Yeah.
Matthew?
Yeah, that was the question. Can I set the version
Can you set the
of?
version? Okay, yeah, I didn't. You faded out for a second, so I just heard
Oh,
can I
sorry.
the version of etcd? No, that's okay.
Oh, sorry.
Um, can you set the version of etcd? Hmm. I don't know why you'd want to, honestly.
Well, here's a kind of a complementary question. In the command line that was generated, you had dash etcd. I just saw that Kubernetes 1.13 is using etcd 3 now. Does that make a difference? Is that related?
Okay, so the way that you would do this via RKE, find my documentation here. The way that you would do this via RKE is version Kubernetes clusters, custom cluster. Oh wait, I'm in Rancher. I need to go to RKE. In the config that you see me that I have open here on the left, there's an option for system images. There it is. So here is where you would set that. So for example, if you were running a version of Kubernetes, well, if you were installing whatever, so we're running 1.11.6 over here, it's going to take the default of etcd, whatever that is in its configuration. But if we specifically wanted to run a different version of etcd, then in the config, under system images, I would just put another line here for etcd, and I would specify which etcd image I wanted to run, and that would take care of it.
Okay, sweet. Okay, we have a couple more questions, but I'm just going to have this one be the last one since we are out of time. This is from Colin, who asks, would you recommend building up a Rancher Kubernetes cluster on Rancher OS with RKE? And if so, would you install it to the system Docker or the user Docker?
So it would go into user Docker, because it's still user space stuff. System Docker is things that are responsible for running the system. So absolutely, I would absolutely recommend it. Running RKE on Rancher OS is really fast and really stable, but you want to do that just with a standard Docker run command, not with system Docker run.
Okay, sweet.
So Matthew, are there more questions? Because what we can do is you can do the wrap up, but then I'm still willing to stay if the people who asked those questions are also willing to stay.
Yeah, there's a few more questions. There's one from Arvind on pulling images from ECR. So there are a few. So if you do want to stay, you can. I can
We
wrap
promise
it
that
up.
we stay until all the questions are answered. So why don't you want to do your wrap up and then we'll just
Yeah,
hang out?
yeah, that
Okay.
sounds good.
I will
Let
stop
me
sharing.
cool. Let me share my screen. And
I'm sorry that this has gone so long, but there's so much
so
information
yeah,
here that it's just really hard to get it in a concise form that still is enough that you guys can walk away from this feeling like you learned something.
yeah. So and just on that note, for more support, more help, many people have asked. This is the URL for the Slack. So slack.rancher.io. It's free to join. Um, you can join the Kubernetes channel. You can also reach out to me and to Adrian. The channel for this specific training is training-0110. So all the people from there can join that one. And we will have a survey when this ends. So if you stay for that, that'd be great. It'll also be emailed to you as well. And finally, in case you did miss it, this is being recorded. So you will receive the recording and the slides and the questions. So that was the wrap up that I wanted to give. So let's go back to the questions and we can keep going. All right. So this is from Arvin. He says, how do you pull images from ECR instead of Docker Hub?
Oh, that's so ECR is interesting in that they do this key rotation thing. We had a solution for that around in Rancher 1.6 under cattle, and I don't know what it is. Matthew, you want to give me back um,
Yeah, let me give you
presentation
control.
thing? Yeah.
Yep.
I forgot what I was saying. Uh, right. Do you see the correct screen now again?
Yes.
Not the wrong screen. Okay, so the answer for that is not Rancher specific. The answer for that is Kubernetes ECR images. Private registry, EKS. Oh, look at that. There's an article up on Medium about how to do that with Rancher.
Amazing. That's awesome.
That is awesome.
That's great.
They're doing my job for me.
That's right.
Okay, so here you go. It's on Medium. Uh, just Google Kubernetes ECR image and you'll find your answer.
Sweet. Okay, let's keep going. Let's see. The next one, this is from Sai. It's a very general question. How do you maintain databases for web applications? Do you point them to one database or a different ones in sync? Question mark,
So
question mark.
yeah, okay, so no, that's an excellent question. Databases for web applications within Kubernetes use a thing called a stateful set. And when you have a stateful set, um, most every application, catalog apps here, say launch. So if I pick, I think we have Redis. So Redis is going to launch as a stateful set, and it'll set up the master and the slave configuration, and these apps understand how to handle basically active-active master stuff. So you'll be able to direct your traffic to any one of them, and they will redirect it to the appropriate one. Even primitive database apps, by comparison, like you think of MySQL master slave replication, and you certainly can't send write traffic to the slave. Well, when you deploy it inside of here, it doesn't actually deploy MariaDB or MySQL, it deploys Percona. And Percona is a modification of MariaDB and MySQL that understands active-active master stuff. So once again, it's a stateful set. You put your stuff up in front of it. You put a service in front of it. Your stuff communicates with the service, and it just works.
Okay.
Next.
Next one, this is from Davey. I run an HA Rancher setup and would like to add an HA storage cluster to it. Which storage system do you recommend for this, and what network speeds are recommended for server-to-server connections?
I love storage. Okay, so provisioning, I don't know where you're running it. If you want to type that, Matt, you can tell me. So not knowing where you're running it and not knowing what you plan to do with it, I can't tell you what to do for network backend. Just, if you can isolate it. Okay, so let's say that you're building it inside of a data center that you control. Ideally, you want dedicated switches for your storage network. And if you can't do that, then you at least want a dedicated VLAN within switches that have a fat enough backplane to do it. If money were no object, I would provision. Again, I don't know where you're running this, so I'm just going to continue to talk about physical infrastructure. I would provision dedicated nodes to run for storage. I would make sure that they had fast cross connects between them on dedicated switching. The truth of the matter is you're probably going to run this somewhere where you don't have access to that kind of stuff, like my house. My house, I'm running a 3-node Rancher cluster inside of Proxmox on some Intel NUC hardware. I've got a Synology NAS acting as an NFS server and another one acting as an iSCSI server. And I either mount iSCSI volumes directly. Now, neither of those are persistent. So I mount iSCSI volumes directly, but certainly if my NAS dies, then bad things happen. So lately, I've been looking at OpenEBS. And OpenEBS, catalog apps, launch, OpenEBS, these guys right here. OpenEBS uses containers to do block level replicated, distributed storage with block level replication. And the way that this works is now I have persistent storage mounted on each of my nodes, or I can actually use the storage on the node itself. I'm running this out of DigitalOcean, so maybe that's a better example. In Dio, on each of my 3 Rancher nodes, I have dedicated block storage from DigitalOcean. And then inside the cluster, I run OpenEBS, and OpenEBS has been assigned each of those backing storage repository, whatever those disks, and it's put them into a pool, and it understands that they're different. And then within Kubernetes, I say I want whatever 5 gigabytes of storage with 3 replicas, and I want it from the storage class that OpenEBS serves. Storage classes within Kubernetes are we don't have storage classes here. Storage classes within Kubernetes are a way for storage classes. There you go. They're a way for pods and deployments and such to ask for storage without caring what's behind it. So they can just ask for 5 gigs of storage from the storage class OpenEBS CStore disk or from NFS client, and they'll just get storage. And Kubernetes is responsible for provisioning that storage via whatever backend is available. So OpenEBS will create 3 containers, 3 pods, each of which is directly mounting storage off of each host. And then it delivers that as a single disk to the pod. And the pod just treats it like a disk. And OpenEBS is responsible for making sure that that content is replicated across all 3 of those physical nodes. So it's essentially replicated across 3 separate disks. That's much faster than using direct iSCSI or using it gives you a lot more flexibility than like standard EBS or standard direct attached cloud storage because you can scale it. It works more like an LVM pool. So if I start to run out of disk, I can just add more disks to the pool, and OpenEBS will just be like, hey, cool, more disk, and it'll start allocating it. It's also cool for block level replication with the use for like databases. I can put a database in front of that, and I don't even necessarily need to run active, passive, or master slave MySQL because I have the storage physically on all three nodes. So if my node where the database is running dies for whatever reason, Kubernetes will move it to another node, and hey, look, the storage is there too, and it just mounts the storage, and the time to recovery is much, much faster. Storage is really complicated, but
Mhm.
OpenEBS is cool. OpenEBS is also built on technology that we developed called Longhorn, and we'll have more stuff about Longhorn coming out later this year.
Yep. Awesome. Okay, next question. Does Kubernetes have a registry like Docker?
Kubernetes itself doesn't have a registry, but it so that's a trick question. Um, it's like saying, does my car have a chimney in it, like my fireplace? They're just two totally different things. Um, Kubernetes uses Docker images, or eventually it'll use other things, containerd, or you can make it run with Rocket and stuff. But most commonly, it runs with Docker. So when you tell Kubernetes deploy something, it goes and gets that Docker image from wherever you told it to go. And that can be Docker Hub. It can be a registry server that you control. It can be another private registry server from like Elasticsearch or whoever. Um, so Kubernetes doesn't need to have a registry. It knows where to go and get the containers. You can run your own private registry servers for your applications using things like Harbor or GitLab or even the Docker registry itself, Quay, Nexus. There's tons of different registry servers. JFrog, Artifactory is another one. So you could run those, and you could theoretically even run them inside of Kubernetes, but you don't want to do that because you'll end up where Kubernetes needs something inside of Kubernetes in order to work, and that's a loop
Mhm.
where things will just fail.
Mm. Awesome. All right. Next one. This is from Ryan. Is there any way to inject other network providers like Contiv and ACI?
Okay, so that's a question that we get, and I don't direct. I'm assuming with our KE because you saw that we support Canal Flannel and Calico.
Hmm.
Um, if you are launching from the UI, I don't think it's possible. However, if you are launching from RKE like this, I think that it is, but I'm not totally sure. I know that I've seen conversations go across in one of our field engineering chat channels about using other network providers, and I've seen people say that yes, it's possible. I don't know how to do it, and I don't think it's a supported configuration. But if that's important to you, please find me on Slack and let me know, and I will get you a better answer.
Cool. Okay. Next one is from Leonardo. To use the Helm CLI in my local environment together with kubectl, do I need to deploy Tiller on the cluster?
Yep. And even if you're not deploying Rancher in an HA format, the instructions on how to provision Tiller for a Rancher, well, okay, so if Rancher, if you're deploying Kubernetes via Rancher, which one am I? I'm training S here. So theoretically over here, we could directly talk to this with Helm because all of the stuff for this exists. Do we have Tiller running over here? Workloads. It's crazy. There should be stuff here. I'm not sure why this isn't showing me anything. Um, let's do this. Cluster train, grab this kubeconfig file, copy to clipboard. Okay. PC get PO dash dash all spaces. Okay, so there's not a tiller deployed here by default. So if I said Helm status, it's going to complain, could not find tiller. All right. So you can step out and come to rancher2.x and come to installation and come to high availability install and come to initialize Helm. And literally, if you follow these steps here, um, down to the China part. So yeah, if you follow these steps here, we just paste all of that. Then in a moment, so we can say control dash keep system, pull out status. So in a moment, Tiller will be installed and then Helm will just work. So even though those instructions are for how to provision Tiller so that you can install Rancher via Helm in an HA environment, if you have any RKE cluster, you can provision Tiller that way.
Okay. All right, let's see the next one. How can I resolve the problem of a Helm command not found on kubectl inside the Rancher interface?
I would need more information on that. That's really specific.
Hmm.
That's a find me on Slack question.
Okay, cool.
Guys,
Sorry,
try
my
to limit your questions to like what we're showing, just because we're so far overboard on time.
yeah,
Limit it to like questions about Rancher, about Kubernetes, um, not specific problems.
yeah. All
Anything
right, next.
conceptual.
And this next one's from Ilya. She says, "Is it possible to add one custom node to an already existing cloud
Oh
provided
yeah,
cluster?"
absolutely. Just take that Docker run command that you used and just go run it on that new node, and it'll join the cluster.
Awesome. Okay, this next one. Once the cluster is up, what if a worker node is unavailable? How would Rancher handle that?
Once the cluster is up, if a worker node is unavailable, how would Rancher handle that? um, so Ilya, here's your Docker run command, so you can just come back in here and you can run it. So if the node is unavailable, Rancher will recognize that the node is unavailable, and it'll report that it's unavailable. By default, that's it. Kubernetes running on the nodes will detect that there's a problem with it. I mean, it depends on what you mean by unavailable. Let's just say that the node dies. So if the node dies, Kubernetes will do its best to move workloads to the remaining nodes in the cluster. And unless there's something outside monitoring the failure of the node that knows how to restart it or do something like that, by default, it's not going to do anything. Options that you have available are to use things like auto-scaling groups inside of Amazon. So Amazon detects that the nodes are dead and restarts them or recreates them. It's actually better. And so if in your cloud config you have that Docker run command, then when the new node comes up, it just joins the cluster and all the workloads get moved over to it, and you stay happily asleep, dreaming of Rancher. In Rancher 2.2, we also have additional metrics. We have a multi-tenant Prometheus installation that is monitoring the entire cluster. Well, it's monitoring all of the clusters that are running. And we can use that to make decisions for what's called horizontal and vertical autoscaling. Horizontal autoscaling is, oh, let's spin up more pods. Vertical autoscaling is, hey, let's spin up more systems. So in that context, while I haven't seen it directly demoed, it would, in my mind, it would be obvious that we can use those things to also detect node failures. And as long as we knew how that node was provisioned, which means it's something that we launched, from one of these guys over here, not an imported cluster and not a custom cluster, but any of this stuff, then, well, actually, if you're up here in the top, if it's any of these hosted Kubernetes providers, they're going to restart the nodes for you. So it's really just down here. As long as we knew how that node was provisioned, then we should be able to spin up a new one.
Okay, sweet. All right, next one. This is from Rian, and there's just a few left, Adrian, so you know.
Okay.
This is from Rian. We have one primary and one DR site. Can we use two Rancher installs, one on each cluster, and import DR on primary Rancher and primary Rancher on DR?
No, that sounds like you want to have two Rancher servers managing each cluster, and that you cannot do. Disaster recovery is interesting. So in that situation, what I would do is I would have primary site and DR site, and I would have one HA Rancher server environment either in one of those sites or in a third location, because all that matters is that the nodes can reach out to the Rancher server. So your Rancher server is HA, and then you also set up etcd database dumps on a whatever frequency is the minimum amount of time you can tolerate failure. So if that's every minute, great. Every 30 minutes, whatever. And you export those offsite. So if your Rancher server cluster fails, there is no impact on the workloads running in your active or your DR site. They're just going to continue to run fine. People are not going to be able to interact with the Rancher server until you spin up a new Rancher server and restore the etcd database into it. That takes minutes. So your time to recovery on that is very, very fast. And then if you lose your active site or your DR site, you still have the Rancher server cluster, assuming it's in a third location. And you can still talk to the site that remains. If you put the Rancher server cluster in your active site, for example, then your worst case scenario is active site fails, you lose active site and the Rancher server, DR site automatically takes up the load, and you need to go and spin up a new Rancher server cluster and restore the etcd snapshots into it. Your time to recovery is still on the order of minutes.
Awesome. So great. Okay, a couple more. This is okay. Here, this is next two are kind of 1.6 to 2.0 questions.
Okay.
I have a 1.6 deployment with 3 environments: dev, test, and production, with the same set of services in each. For Rancher 2.x, would that be 3 clusters or a single cluster with multiple projects and then a
Yeah.
matching set of namespaces per project?
So you can do that either with one project and 3 namespaces, but I think you're better off doing 3 projects and matching namespaces. But you definitely don't need 3 clusters.
Okay, awesome. Um, okay, here's the next one. What is the role of Cortex in Rancher 1.6? Is that equivalent to Ingress in Rancher 2.x?
I don't even know what Cortex is. I've
Okay,
never heard of that.
okay, cool. All right, we'll ask on Slack. Um, and then here's the final one. In a single node install with an etcd and etcd and control plane node, what would happen if the Rancher slash Rancher container goes down? Does scheduling continue to work?
Yeah. So there's in a single node install. So basically, you have a single node install, but it's managing a cluster, right? Well, actually, he can't respond because
Yeah.
I was asking you.
Yeah, I
I'm
don't
tired.
know.
You're doing this for 2.5 hours.
I
Tell
know.
me, Matthew, what do you mean by that question? Okay, repeat the question to me, please, one more time.
Sure, sure. In a single node install with an etcd and control plane node, what would happen if the Rancher slash Rancher container goes down? Does scheduling continue to work?
So the question kind of doesn't make sense because in a single node install, you actually just have a single container. Um, so it sounds like in a single node install of Rancher that's managing something else, what happens if the Rancher server container goes down? And I can answer that by saying in a single node install that's managing an external Kubernetes cluster, what happens if the Rancher server goes down in the sense of what happens to the stuff running inside of Kubernetes? All of the scheduling and everything related to the workloads running inside of Kubernetes is being managed by that Kubernetes cluster. It's not like the Rancher server is constantly managing stuff. It's not. It assigns all of that to the Kubernetes cluster, and so you can literally shut the Rancher server down, which actually in a single node upgrade is what you do for upgrades, and everything running inside of Kubernetes will just continue to run. If something disastrous happens to the node, you need to make sure that you are running backups and that those backups are off of the node. And as long as you are treating the Rancher server as a data container, and there's information on this on our site on how to do this, but essentially as long as you have a backup of the container somewhere else, you can just spin it back up and it'll just start managing the nodes the same way that they were, and everything's fine. There's no impact.
Amazing. Awesome. And that was the last question, Adrian. And so yeah, I mean we can wrap up. We still have a ton of people on the line, so just thank you everybody for being here. Anything else you want to say, Adrian, before we close out?
Just thank you all for staying. I know that webinars that run this long are exhausting. So yeah, I really appreciate you guys' attention. I hope I've answered all of your questions. If I haven't, find me on Slack. And while I do also have a day job of actually working at Rancher, I'll do my best to make sure that any additional questions you guys have are answered. And everybody on Slack is also really good. Like if I'm not available, the general channel, the Kubernetes channel, we have a huge user base that are always logged in and everybody's willing to help everybody else out. So I look forward to seeing you guys there.
Awesome. And I want to let everybody know as well that we do these intro trainings every week, and we're also going to be starting a new kind of more advanced track as well. So we have more trainings coming. So please keep an eye out. Rancher.com/training. You'll see them there. And yeah, just thank you so much. There will be a survey at the end, so please leave your feedback. It really helps us make these better and also create new types of trainings that you guys want to see. All right. Have a great rest of your week, everybody. Talk to y'all later.
Thanks, everyone. Bye now.